Hello, everybody. I am Maria João, and I'm your host for today. Today, we're going to be talking about backend with our two colleagues, Oleksii and Sviatoslav. And I am from Porto. I can see already in the chat some people are from Porto as well.
Hello, everybody.
I can see people from Turkey, people from Pakistan. Someone from Persia. That is amazing. I think this is the first time we've had someone from Persia at one of our dxTech talks, at least that I can remember. But I can see a lot of people. Someone from Turkey that is based in Porto currently. That's so nice. I hope that you are enjoying Portugal. Bulgaria as well. We also have an office in Bulgaria and another one in Georgia. We also have in Turkey, but I will tell you all about it later. I can see some people from Romania. That's so nice. All countries that I would love to go to. Well, I've been to Bulgaria before. It's a lovely country, but I would love to go to Georgia and Pakistan as well. I've heard the mountains are amazing. But keep on telling us where you're from. I'm loving to see it. We still have to wait a few minutes for everyone to join, so I'm happy to see where everyone is from. We have someone from India. That's cool. That's nice. We do have some people from India also working at our office in Portugal. That's where I'm located, but maybe we have some people in other locations as well. But I do know that we have a lot of people from India, and it's so interesting because every time I need to find out something about technology. I go because I don't work in technology. I work at Devexperts, but I'm in HR. Every time I have to go to know something about technology, I always go on YouTube and I know there's someone from India that is ready to help. So I love that. Have you ever been in Turkey? Yes, I have been in Turkey, but it was Istanbul. Sorry, not Istanbul. I want to go to Istanbul. I have been to Antalya, which was just lovely. Okay, so I guess we have some people already with us, so we can start. And enough talking about myself, and let's talk a bit about Devexperts. This is our TX Tech Talk, which is a series of three free tech meetups that we organized. We, as Devexperts, if you don't know Devexperts, we specialize in the development of financial software solutions and services for the global capital markets industry. We were founded in 2002 and we have R&D centers in a lot of locations. Some of them I already talked about before, but they are Jersey City, Porto, Vilnius, Munich, Dublin, Tbilisi, Sofia, and Istanbul as well. We launched this project a while ago, so we could be more in touch with the tech community, so we could share expertise in fintech and we could discuss some projects, technologies, the tools that we use. And besides online, we also organize these events in person in Sofia, Georgia, and Porto. We haven't done it in a little while, but hopefully they will come back soon. And if you want to stay up to date with all of our events, you can follow us on social media. We post them on Meetup, Facebook, Instagram, and LinkedIn. So you can follow us to stay in touch about upcoming events. We announce all of them in our corporate profiles. But I have a little secret that hasn't been announced yet. We're doing another DX Tech Talk next month on the 28th of May, and it will be about front end. So this is a little secret that I will let you guys into. So if you are full stack, I know that most people here are in backend, but if you're full stack, you'll be able to join a front end event very soon. Today we have two programs. We have in program two tech talks, and there will be around 20 minutes each. And then at the end, we will have questions. So feel free to drop your questions in the chat whenever you have them, and I will read them to the speaker at the end, and they will answer all of your questions. So our first speaker of today is Oleksii. Oleksii is a full stack developer at Devexperts. He's specialized in backend development for enterprise financial systems. He has over or almost 5 years of experience in software engineering. And well, he has understand that a lot of people don't know the fintech world. A lot of developers are new to it and sometimes have hard time understanding it. So he will tell us all that we need to learn. So, Oleksii, welcome to the stage.
Hello there, welcome. Do you see me? Yep, I'm here.
We can.
Hello there.
How are you?
Yeah, thank you, I'm pretty fine. So, should we start?
Yes, let's do it.
Okay, I'll share my screen, share the presentation. I think this screen is shareable. Yep, right here. So, hello there. Hello there, and welcome to dxTechTalk session by Backend Day. So today's topic is how to simulate market data and why is it harder than it looks. So let's start. I'm Oleksii Niechaiev, and let's talk briefly about me. I'm a software developer. I've been working at Devexperts for almost 5 years. I'm from Ukraine, and I'm happy to make other people's life happier. This is me on the photo, by the way. Next. Today's topic is market data simulation. Let's ask the primary question. Why do we need to do this in the first place? Why do you need to simulate market data, apparently? By the way, if you are not a backend developer, if you are a front-end developer or QA engineer or support engineer, it doesn't matter for this current presentation because I want to dive deep into the deep details in this presentation about backend implementations or front-end implementations because I will speak about this and I'll talk about this in more broader context. First, if you don't have enough data, this method will suit you. And if you are not permitted to use real data, sometimes in our fintech world, we are not permitted to use real data for some of our systems for UAT or Stage or QA platform that are not exposed to the outer world, but is used for other parties. Or if you want to test your system or email algorithm on a brand new data set that has not been seen before. For example, if you doing algo trading or email algo trading, it will be really helpful for you to implement such system to train your algorithms to new data, because sometimes if you train your algorithm or ML algorithm, the data is scarce. Please write plus in the chat who do algo trading or tried algo trading at least once in their life. I don't see pluses. Okay, no algo tradings in the chat. Another reasons why you need to simulate market data. If you want to learn something new about markets and how they work as an education purpose, if you want to challenge yourself, or if you want to test if technical analysis, aka mel astrology, is real, I think I assume you know what technical analysis is, but it's basically those strange patterns. When you see these patterns on the chart and you predict the price. I don't believe in this stuff, but anyway. So what we'll simulate today? We will simulate candle charts and charts in general. As you can see here, this is a chart. This is a chart of S&P 500, kind of an index of 500 most valuable companies of the United States, and it's the price chart of this index. Please note how this chart behaves, how this chart is irregular, what patterns does this chart does the chart have. It will be important in the future. So to understand what will we simulate, let's understand what is the candle, what is the basic principle, what is the basic term of this market data. As you can see, this chart is consisted of those small bars, and those small bars, green and red, they are called candles. And candles could be green and red. The green candle, it's called bullish candles, and it represents the price movement up. and the bearish candle represents the price movement down. So in the bullish candle or green candle, the open price is the lower margin of this candle, and it represents the starting price of this candle. Each candle represents price movement during fixed piece of time, 1 hour, 1 minute, 1 day. For example, here we have 1 day candles. So open is the starting price of the day, close is the last price of the day, low is the lowest price of the current day that the candle represents, and high is the highest price, and vice versa in the bearish and the red candles, where close price is down the chart and open is up the chart. So to test this hypothesis, I built a market data simulator, a really small market data simulator, where we will run our strategies and run our different strategies how to simulate data. So first approach, when you want to simulate data or you want to implement some kind of thing for yourself, for your company, for your work, what you're gonna do? You'll go to the Cloud Code or ChatGPT and ask them to implement such algorithm or such thing, and they will implement it for you. Okay. Let's assume that we also went to ChatGPT or other LLM and asked about the price simulation or chart simulation, and what they build usually when they are asked to build such things. They built the first and the most naive approach based on the last price. For example, have you ever wondered how price is made on the market? Why some prices are 100%, $100, and some things cost $2? It's a really interesting question, especially in financial markets, because, for example, in banana, you can count the transportation, the cost, how much money did you spend on producing those banana or those products. But in financial markets, the things are a little bit different. So let's assume that the next price will diverge from the current price by some amount of percent, by some step, I don't know, in the range of 1% or 2% or 3%, by the range of parameter. And the baseline or the base price will be $100. And ta-da! Here's our first approach, our first data simulation. Please, could you write in the chat? Does it seem plausible for you? I don't think so. So it looks like chart, it looks like candles, it has wicks, it has the lowest, it has highest prices, and it seems like a real data, but it's not real data, and you can definitely see that it's not real data. In the real data, you don't see those green or red bars, those consequences of red bars, these stairs and these ladders. Yeah, actually you can see and you can observe in real market such market data, but it's not usually BTC price or EURUSD major forexes prices, or I don't know, S&P 500 price. It's not a high liquidity market. But what we want to do is a high liquidity market, and the simulated data that would be really likeness, that will be plausible, and that will be like the real data. Yeah, actually there are a lot of tools how we can verify is it how close this data is to real data. There are a lot of mathematical conceptions, there are a lot of mathematical constants and mathematical equations how we can figure out does it look like real data, or is not or isn't. I will show it at the end of the presentation if you want so, but right now I won't deepen into this stuff. So it doesn't look like real data. It doesn't look like real S&P 500 chart. No. Something is wrong. The previous approach was named as Monte Carlo approach when we basically flipped a coin to determine the next price movement, determine the next chart, chart candle. Let's stop a little bit and think about the simulation process itself. Do we need to simulate the data itself produced by a process, or the process itself to simulate this data? Let's figure it out. Let's simulate the market. And to simulate the market, we need to think a little bit about how market works. Usually in the market, there are two roles, maker and taker. Maker is the guy who proposes orders. For example, when you come to the market, maker is the seller and he proposes you to buy his bananas, for example, for $1.50. And he places these orders, $1.50, $1.50. And you, as a taker, buy these bananas. Or the situation could be different. The situation could be vice versa in the financial markets as well. Maker is someone who places an order by order, and he proposes to buy some instrument, some financial instrument for example, $1. So he places these orders and he proposes to buy this $1, and taker decides does he agree to sell his bananas or to sell his products, financial instrument, to sell his Bitcoin for $1 or not? Is it acceptable price for him or not? So the situation could be different. A maker could be seller and buyer, and taker also could be seller and buyer. It's not the seller and buyer distinction. It's another dimension per se. So, and taker can can sell these bananas and fulfill this order. So, when there are a bunch of makers, the order book is formed. Order book, to imagine the order book and what it is, you need to imagine a market, a real market where there are a lot of stalls and a lot of tables with buyers and with sellers. For example, on the very left side of this infinite by length market, infinite by length table, there will be buyers that will buy your product, that will propose orders to buy your product or buy bananas for the insignificant amount of money. For $0 is 10 cents, 20 cents, 30 cents, and they will go subsequently in the order of ascending, in ascending order. And somewhere in the middle there will be sellers. There will be sellers that will propose to sell these bananas for the price greater than the greatest buy price. If there would be another price, for example, if there would be a seller with the price 90 cents, this seller would be immediately matched with the buyer, with the first buyer, because their prices match, and the trade happens. It's the deal. He wants to sell it for 90 cents, and there is a buyer who wants to buy it for 95 cents. It's a match. But usually there are two clusters. There is a cluster of buyers that they are sitting on their orders, buy orders, and there is a cluster of sellers. They are sitting on their sell orders. Okay, we are figuring out what is maker, what is taker, what is order book, and how traders behave and what they do in the market, in the financial market. Let's simulate this process. So I simulated some amount of traders. Some of them were takers, some of them were makers, and I started the simulation, and it looked like this. It doesn't seem it doesn't seem like a real market data either. It doesn't seem like chart at all. It looks like a Netflix intro. Have you seen Netflix intro? Okay. So the second try backfired significantly. And at this point of time, I thought, what about it's not about the trading? What about it's not about the numbers? Because I substituted the real human experience with some kind of random choice, some random numbers. Maybe it's all psychology. What if they are random traders? What if they are trend follower traders? What if they are high frequency traders? What if there are whales on the market? Whales are the traders that place significantly large orders. High frequency traders, the third bullet point, are the traders who tries to execute their orders as fast as possible, that they place the buy orders above the baseline, above the current price, they place the sell orders below the baseline, below the current price, and they try to make their money, make their strategy work based on these speculations. It's basically speculation. And trend follow the traders. When the price goes up, I'll buy the Bitcoin. When the price goes down, I'll sell the Bitcoin. Something like that. So let's try this approach. It will be what number? Third. It will be third try. Let's try it. Yep. It doesn't work. Let's stop a little bit. Let's return to the second approach with makers and takers. The second approach in the literature, in the papers, the research papers, this approach is called microstructure simulation with agentic simulation. Sorry, my Brazilian accent. With agentic simulation. What does it mean, microstructure? It means that you don't observe the market as something whole and hollow. You observe each transaction as a separate, and you create separate and independent agents to perform trades and perform orders and place and trade orders. This is why it's called microstructure simulation. So let's return to this second approach, to the microstructure simulation with makers and takers. The first time I made the proportion 50 by 50. 50% of them were makers and 50% of them were takers. But in the real market, in the real financial markets, it's not how they work, because usually maker, when they place an order on the exchange, they pay fee for that. They pay commission to be able to trade and to be able to place their order. If you trade it somewhere, for example, for a broker or for some crypto exchange, you probably know that. So I slightly changed the ratio between the makers and takers. So it's 5 over 95%. And there will be more takers than makers. So let's try it. Oh, seems like we got it. Seems like, yeah, it looks like S&P 500. Yeah, it has some kind of little disruptions here. Can I draw? It has some little disruptions here, some little disruptions here, but you usually observe these little disruptions in the real market data as well. And this market data is irregular. Is irregular enough, and I have a lot of metrics to prove it. I'll show it in the end if you're interested. So let's go to the summary. How to go? Yep. So summary. Sometimes to simulate the data, you need to simulate the process that produces the data. It's called microstructure simulation. You need to look deeply and always think about approaches that you use. Perhaps if you hit a wall, you need to change the approach and jump over the wall or try something different. And instead of focusing on small details and parameters. And I think it's always necessary to have some base knowledge before asking an AI to implement a thing or asking AI to for that knowledge. Otherwise, it will use the most common and naive approach. But I need to highlight that sometimes you don't need the most sophisticated and the most strange approach that you have. Sometimes the most naive approach is the best approach because, for example, if you are testing your chart software and you need to show million candles and to test how it works with million or 5 million of candles, for example, it could be a thing if you have 1 minute candles. You just need to produce the simplest data as you can. So that's it. You need to always think about what approach you need and what result you need from this data. Contact us. Here are our contacts. Here's the repo of this market simulator. Please, it's not none of the mentioned here is a trading advice. It's not a trading advice. Please don't risk your money and don't trade if you don't know what you are doing. So that's it. If you want to talk about the metrics, about the standard deviation, about tail behavior of the other approaches, for example, Gaussian noise approach, you're welcome. Why didn't I use a Gaussian noise approach? It's not, in the first place, it's not so cool because it's actually much more interesting to simulate the market process itself in the first place. In the second place, it has a strange and very ordinary tail behavior that looks like a Monte Carlo approach. Here you can see tail behavior 2 sigma or standard deviation and 3 standard deviation. And if you have a Gaussian approach, if you generate candles or market data using Gaussian white noise, you have a standard deviation above 3 standard. You have tail behavior above 3 standard deviation, 0% almost every time. But if you generate market data using microstructure approach, you have 1% to 0.5%. It's not enough because in the real data you have 1.5%, 1.4, 1.8%, and autocorrelation is also different. Autocorrelation is the ability of data to repeat itself. If you say it in simple words. So if you generate your data using some kind of Monte Carlo approach or Gaussian white noise approach, sometimes it has high autocorrelation and sometimes it can reproduce itself. So you can try it. You can, let me return to the previous slide. You can scan the repo and you can try this by yourself. You can tweak the strategies. And that's all from my side.
Thank you so much, Oleksii. That was great. And we already have like so many questions in the chat. So I will just move to that immediately because there's truly a lot of people just asking questions. There were a few comments as well. First of all, everyone loved your astrology joke, including me.
Okay.
But we do have some people here. So the first question is, can you share a bit about how you simulate your development data in practice?
In practice. So in practice, we didn't need to simulate naked market data out of blue, but we needed to disguise the real market data to the point that it doesn't like it's not like a real data anymore. So we needed to take the real data and disguise it. to the point it doesn't look like real data. So it's kind of similar thing. It's really similar because it uses the same metrics. You can use the same approaches, but it's kind of different in the same time because you don't need to generate it from the zero, from out of blue, from the empty space. You already have real data that you need to disguise and you need to adjust and tweak.
Cool. Okay. Then someone said that those candles sound similar to bull and bear markets. This is a comment, not really a question, but I will read the comments also so you know about them. While simulating market data, how do you ensure the generated data preserves realistic OHLC constraints and market behavior?
Okay. Yes, it seems like this comment was written before the actual metrics. So I have this metrics table where I have some kind of statistical and mathematical calculations, where I have tail behavior, where I have autocorrelation, where I have skewness. Skewness it's the measure that measures whether the data is more stretched to the left or to the right. The positive it means to the right, the negative it means to the left. Kurtosis, volatility clustering, these strange words, complex words. So that's it. Tail behavior is the term that describes what happens at the extreme ends of the distribution. For example, if you simulate your data and you generate your real data, you have this normal distribution, Gaussian distribution. Sorry, it's strange. It's not a real Gaussian distribution. I painted by hand, and you usually have this mathematical bell. And this tail behavior describes what happens at the very ends, this end and this end of this Gaussian bell. So usually in the real market data, it's not a real bell because you have spikes, you have market shifts, you have panics, especially in the last years. But when you generate data using other techniques, you tend to shape your data as this normal distribution, is Gaussian distribution. So I think this the most significant metrics. It was the most significant metrics for me.
Okay, thank you. Yes, that question was indeed done before you moved on. It was at the beginning of the presentation, but nevertheless. Um, do the models that you use the real-time data and are they public? Sorry, published.
Yeah, they are published. They are published in, to the GitHub repository, and they don't use real market data, but there is some kind of excerpts of real historic data fetched by from Yahoo Finance and Binance and Bybit exchange, crypto exchanges, different crypto exchanges using public APIs. You have public APIs for a lot of brokers, and you can do it by yourself using Cloud Code or just Python if you know Python or any other programming language to fetch this data and save to your computer, to save to PC. It's not a problem to use real data, but it's not a real ticking data. It's just data stored in the file where you can load this data and check the metrics, how the real data behaves and what metrics it produces.
Awesome. Then we had another question, but it was actually answered. So someone asked, what does HFT stand for? And Andre Freitas said high frequency trading. That's true, I assume.
Yeah, I
Okay.
think that's all.
There is one last question, and then we're moving on. It is, can you use multiple data sources and aggregated OCLC volume and liquidity to have optimized data?
Honestly, I haven't tried this. But I think it's a really interesting point of view and it's a really interesting idea. But I don't know in which point and how you can imagine how you can merge this and how you can couple and bind this data together, because all of this OHLS, sorry, OHLC, they are separate data sets, and they have a different clustering, they have a different metrics, and they're simply different data sets. I haven't thought about this, but it's really interesting. I will dig into this.
Thank you so much, Oleksii. We have some comments of people saying that this is great, was very interesting, that you're an amazing speaker, which obviously I am not surprised because I've seen you in action many times. If you guys have any more questions I didn't have any time to answer, I am sure that Oleksii would not mind answering via LinkedIn or something. He's the nicest person ever. Thank you so much, Oleksii, and I can't wait to have you as a speaker at a Backend event in person, maybe next semester, who knows. But
Yeah.
thank you so much, and thank you also, guys, for your questions. And now it's time for our second speaker.
Thank you so much. Don't risk your money.
Yes, thank you. So our second speaker is called Sviatoslav. He is a seasoned technology leader with over 18 years of experience in software development and also engineering management. He's a former CTO and co-founder of a web development agency, and he now works as a fractional CTO and full stack developer. A lot of difficult words. Helping companies scale their technology and build high-performing teams and also deliver robust digital products. Thank you so much for agreeing to being a speaker, Sviatoslav. Welcome to the stage, and I'm so sorry if I mispronounce your names. I do it all the time.
Yeah, that's okay. That's
Hopefully I
perfect.
did. Okay, so welcome to the stage, and thank you
Yeah,
so
thank
much
you
for
for having me.
agreeing. And whenever you're ready, you can start your presentation.
Yeah, let me show share my screen. I'm basically ready. So keynote, please tell me if
Yes,
you
it's
can
all
see
good.
it.
We can see it.
Okay. And now you still can see it?
Yes, perfect.
Perfect. Okay, then let's start. Okay, so today I would like to speak about how we are building the agents nowadays. How can we make our programs, our software, like more smarter? A little bit tricks with the LLM. First of all, let me introduce myself. My name is Sviat, and I first met the computer when I was 5 years old. At 10 years old, I wrote my first line of code, and back then it was just pure curiosity. But this was like the starting of my programming career, and I was always thinking about how can I make our programs like more smart, how we can make it not just tools, but like real robots or something like that. So like I was dreaming about AI because I read a lot of literature about the future, about the robots and so on. But as a Howard Stark in the Marvel movies, I was limited by the technology in those days. I even was trying to build the website where was only one input, where you can put the question and get the answer for this question. Nowadays, we have a ChatGPT, we have a Claude, Gemini, and so on, where we can actually ask any question and get the answer for these questions. But back at the days, that was not possible. But now, of course, with LLM, it's not longer a question, it's a reality. And we are building our apps now differently. So after I finish my presentation, I will cover the hierarchy. I mean, through this presentation, I will cover the hierarchy of LLM-powered apps. I will show you the different levels of integration and how they affect our code. Also, I will go through the case study. It's the community-driven quiz generator bot that I've built, and we go through the whole process of building it, and I will show you the problems that I faced and how I was solved it. So, and through this, case study, we will see the evolution from a fragile prompt to like the stable agentic architecture. And of course, at the end, you will understand the art of building the stable LLM systems. And also, I will show you the production-ready patterns, architecture patterns for your own projects, how you can bring it into your own apps. And also, I will show you the exact prompts that you can use as a template for your needs. So when the ChatGPT becomes to the market and we all was so excited about it, I was thinking about, hey, then just bringing this to my app is just an API call, right? So I just need to do one call, get the response, and that's it. But the reality is a little bit more complex than that. And at that point, I want to briefly explain the levels of the LLM engineering, so how we can use the LLM in our apps. There is basically 5 different levels of the implementation, and the simplest 0 level is just simple processor. It's when we are just running the request to the LLM, getting the response, and just printing it. Basically, the ChatGPT chat, Claude chat, and other chats is doing the exact same process. So they just doing the API call, getting the response, and printing it to the user. This is something that we can now see in almost every app. So a lot of people just bring in this 0 simple processor level into their apps and they think that this makes apps smarter or better. But in fact, no, it's not. Because in reality, the LLM doesn't affect our code at all. And the level when it starts, the first level calls router. So router is when the LLM response affects which one part of code will be executed. Basically, we're just wrapping the LLM call into if-else statement, and based on what we're getting from the response, we are executing one or another part of our code. This is already something smart, something new in our code, because before the LLMs, it was not possible to just do this flex decision maker. But today we can do this with only one API and simple if-else statement. But then the API providers, I mean the LLM providers, they invented something that calls tool call. Tool call is basically when the LLM knows which methods, which functions do you have in your code base, and they just asking you to execute it. So in reality, before your request, you're just describing which methods are available for the LLM, and then in response, LLM could respond to you with, hey, please run this method with these parameters and give me the output. So then your code is doing this execution and then doing another API call to the LLM with the previous conversation and the tool output. This brings like the new level to the application, because now the LLM can actually execute your code. It's not just like the if-else decision, is direct execution. Of course, LLM doesn't execute at all. LLM is just token generator. Your code executes your code, but LLM tells what exactly code should be executed. This is a big step forward, because if you're used like Codex or Claude Code, you already seen this when the agent is trying to execute something, like to find file, to write something in file, and so on. With the tools, we can make really, really smart apps, because now we can work with the precise information, not just the hallucination from the LLM, but we can just go to our database, fetch data, and get this data to the LLM. LLM will process it as before, as like you just copy paste it in the chat, but it will be done through the code. The next step is the multi-step agent. And basically, multi-step agent is just infinity loop with the condition. So you just prompt the task to the LLM. Our code is starting this infinity loop, and the condition is simple. Are we done with this task, or we need to run another tool call, or we need to run another API request? This is pretty simple concept, but it's like doing a lot. Again, the Claude Code, Gemini, CLI, Codex, they all basically the multi-step agents. So it's just infinity loop, which is trying to call tools and just waiting response from the LLM when it says, okay, we're done. And multi-agent as just evolution is when the one agent can spawn the sub-agent, but basically the architecture is the same infinity loop. So a little bit background. I have a community of the beginners of developers, and I'm trying to help them to learn programming and to become better engineers. And we discovered the most excited way of learning is just to using quizzes. So they just have questions with some options to answer. They trying to answer as they understand it, and if they're right, okay, cool, +1 to your karma, and if not, then we are explaining what is wrong, how it should be processed, and why they choose the wrong answer. And to do this, I decided, okay, I cannot like generate a lot of quizzes by myself. I need to bring the LLM to do this. And my first approach was really naive. So this is the architecture of how the first version of this quiz generator was made. We were getting the message from the Telegram, and then just from the text, we were extracting the topic. Like the community member could send just a message like, give me a quiz about the HTML, and we are just extracting this quiz about HTML. And then we passing it to the LLM to generate exact quiz, and then just generated quiz were sent it back to the Telegram. Scheme is pretty simple. It's like 0 level, it's simple processor. And the first version of prompt was really too simple too. Like this, create a short programming quiz with one question, respond only with JSON in the following format. And if you know how LLM works, you know that this is just token generator. And if you give it like the nearly same input, it will give you like the nearly same output. And this was a really big problem because, as you see, the prompt is pretty generic. And when we are trying like to ask it a few times to generate quiz about HTML, we get like really similar questions. And that was not the case at all for us. And of course, I just tried to implement my whole prompt engineering skills. To be honest, I just used my free and open source tool called Prism. You can find it in my GitHub account. It's the like prompt IDE to build, test, and improve your prompts. Of course, with the help of the LLM, but still, with the Prism, we build this kind of prompt where we already have a role for this quiz generator. We have question requirements because we have like strict requirement about this answer. It should be 200 characters, or we need like 3 to 6 options. And with this prompt and with this architecture, we already starting to get really nice quizzes that was like really good to use. But there was a problem that the people in community pretty lazy, and they just starting to use the same prompt like, give me React quiz, give me HTML quiz, give me backend quiz. And as I said, if we have nearly the same input, we will have nearly the same output. And this becomes a big problem because we have like, if we try to generate 10 quizzes, like 7 would be nearly the same. It's not a good, it's not appropriate for us. So I start to think about how could I, like, what can I do with this? How can we fix it? And of course, a solution is bring another LLM in our chain. But before that, I had a like pretty typical developer solution. I decided to create a list of pre-written modifiers. It's just kind of creative modifiers. You can see like make the question a bit unexpected or avoid the most obvious angle of the topic. My main idea is to just add these modifiers to the prompt to make prompt not the exactly same. And if we have like two requests about generate HTML quiz, one of them could be with extender like make the question a bit unexpected, and second one could be with I don't know, avoid the most obvious angle. And the output should be a little bit different. But this solution, unfortunately, didn't solve anything. We just expand the scale of the problem, but problem itself was obvious. And then I start thinking about, okay, so maybe we can bring the LLM here and try to ask to help. So because LLM could generate tokens, and if we give them topic, it could generate more topics based on this initial prompt. So then our architecture scheme is a little bit expanded with the extra step, LLM theme extender. And now when we are getting the message, when we are fetching the topic from this message, we are sending it first to the LLM theme extender, which is trying to give us like more creative version of the same topic. And then we are picking the random from this list and passing it to the main LLM, which is generating quiz, and then we are sending it to the Telegram. Of course, it was like in case I'm adding the creative modifier on each step, just to bring more random in this process. The architecture is the only half of the work. The other half is the prompt itself, because with this prompt, I was struggling a lot. Because again, if we are doing the same input, we will get nearly the same output. And the main job for this prompt is somehow with the same input, generate not the same, like different outputs. That was like challenge, but somehow with the Prism, with the other LLMs, we managed to do this. And this version is already good. Current version, we a little bit adjusted it, so it's even better. But this is, as the example, is already good. So we bring the role here, and we describe that this LLM should get the raw topic and just extend it to like 5 to 10 specific subtopics. The second part of this prompt is just output format and how we expecting the result. But here we can see the example. For example, for the topic Git, we will have like the subtopics like the using interactive freebase, or the purpose of the Git attribute files, or how the Git cherry pick works, and so on. As you see, like from this like really poor Git topic, we get this rich subtopics, which is already good. And I thought we bring the better solution, we make the things better, but in reality, we made them worse. Because for some reason, some answers was literally in the question, like in this screenshot you see, there is a comment which says error here, catch is missed for processing errors. And I don't see any reason for quiz like this exist, because again, it's not challenging you, it gives you the answer right in the question, and it's not appropriate for us at all. And at this point, I understand that we need some kind of quality control. And of course, we have two options as always. So the one option was a manual review. I thought first, like maybe the generated quiz will be sent for me first, and then I need to approve it or disapprove it, and but it's not a good solution, because at least it will increase the time of people requesting the quiz, and then quiz is actually posting into the channel when it was requested. Because I could be busy, I could just miss the notifications, and so this is not the case at all. Second option that we have, of course, is LLM-based validation. And this in mind, we have a third extra step in our architecture scheme, which is the LLM validator. And basically what it's doing is just checking the final generated quiz and checking is it valid or invalid. And if it's invalid, then we are just going back to the previous step and trying to regenerate quiz again. In current scheme, we even evolved it a little bit more, because now we have a threshold for 3 tries. Like if we can generate valid quiz for 3 times, we are going 2 steps back and we are trying to extend new theme. So we try to choose different theme and again generate the quiz. Pay attention that in this scheme, so the first version of scheme was just 1 LLM request. Now there's a 3 LLM request. Of course, this will increase your latency. So this will increase the time of processing this whole process. And to make it not so slow, we use the different models. For the theme extender, we use the mini model, which is pretty fast because there's no like this complicated compute needed to extend the theme. For the main LLM, we used like regular heavy model, and for the validator, we use the mini model as well. So like these small steps could be handled with the mini models just to reduce the latency and increase the speed of the whole process. With this prompt, I was struggling not a lot, but it was not so easy because this at first version, this was too strict. And I found that some really good, really valid quiz were marked as invalid. And for some reason, we're trying to regenerate. And there was a challenge to find the balance between the strictness so that we don't pass really bad questions and softness that we don't reject really good questions. But with this version of prompt, it works already fine. I didn't see any good question that was rejected, and everything that is rejected is really sloppy. So doing this work very, very good. Validation rules is the most hard part of this prompt, because this is the actual task. This is the actual logic behind this layer in our architecture. So yeah, with this prompt, it works well. Now we have a stable system that generates our quizzes, and people are so happy to have this functionality. Let's see the evolution. So I started with the simple 0-step just processor. So I was relying on the LLM. Then I decided to bring the power back in my hands, and version 3 is already router. So the response from the LLM is decides which part of code we should execute. Should we send it to the Telegram or should we regenerate it? The main idea that I want to bring here is to show you that you need to think of LLM system not as a black box, but as a set of tools. Because I have a friend who thought that he can just create really huge prompt with the all instruction, with the all task, and just throw it into LLM and get the result that he can use in his application. And from my perspective, this is not the good approach. So this is not how can we use the LLM in our system, because we still need to rely on code, because code is predictable. LLM is not predictable. It's just token generator. It's just random machines that generates some symbols that then you can read and understand. So main idea is to combine them into pipelines, generators, editors, validators to make our apps more stable and reliable. I believe this is the key to reliability. So basically, that's it from my side. Any questions?
Thank you so much. That was great. As someone that does not understand coding whatsoever, I could understand some things, which is interesting. Yes, we do have some questions. So someone said if you know about RAG, R-A-G, I don't know
Yep.
how to pronounce it.
So yeah, I do know about RAG. It's basically when we have a database that is ready for LLM. So basically LLM is stored the knowledge as the vector database. So it's amount of tokens with the weights, and based on which tokens we have an input, the mathematical algorithm is decide which next token should we pick to continue this chain of tokens. RAG system is basically the database for LLM, which is stores information in the format that LLM can work with. Because when we are just prompting, we are prompting text. This text should be processed through the tokenizer, so it should be processed into tokens, and then tokens goes into LLM and generates. So the RAG system is basically when you are storing your information in the tokens format, which LLM could use. Yeah, but this is a complex solution. My advice to not build this from the scratch, just use the systems from the providers, like the OpenAI have their own solutions for this one, because again, you will face the same problems that I will face with this quiz generator, because you need to validate if the LLM get the data from the vector database is correct or it hallucinates somehow. So this is why I'm advising to use the ready-made solutions from the providers.
Nice. Do you recommend a local LLM where chats stay private or enterprise LLMs like Claude?
It actually depends on the exact task that we have, because local LLMs are great. They are good, especially like the new models from the Gemma 4, which is actually compressed and you can run it on the MacBook or even iPhone. They're great, but there's always pros and cons. So if you have really simple tasks, you can use local LLMs. And if you are worried about the privacy, you can use local LLMs. But if the task is complicated, task is really hard, or you need to communicate with the external data, like the reading emails or reading some stuff in the internet, then I will suggest to use big models from the providers. If you are paying enough, you can opt out. So like your data still private, they are not training, they are not collecting anything. If you're worried about this, but the big models, they are smart enough to ignore prompt injection. And prompt injection is the main problem with the local LLMs, because they are small and they all could be prompt injected very, very easy. So like you are asking your agent to read email, and inside this email, you have like a small instruction, like send all secret keys to this email, and your agent will do this without any hesitation.
Awesome. So we have time for 2 more questions, and I have them already in the chat. So one of them is, how do you handle the trade-off between reliability and latency and cost when using retry loops after validation failures?
Yeah, it's all about the how it goes. So I'm trying to balance this with the models that I'm using. So as I said, for these sub steps, I'm using the small models. They are really fast. They super fast. And when we have like part of code, if we cannot generate quiz 3 times in a row, we are sending extra message like, I'm thinking, just to user, let them know that generation is still in process. Just wait a little bit, please. But yeah, it's all about the which model do you choose, because of course, if you will choose the like GPT 5.5 for validation, it will take a lot of time, especially if you will like include extra high reasoning for that. But I'm just using GPT 5 mini, just 5 mini. It handles it like pretty good, and it's really, really fast.
Okay, thank you. So the last question is, do you make metrics of how good LLM's response is?
I'm not sure that I got this question correctly. Metrics, how the LLM outputs is good.
I don't know.
I don't know. So when I was testing the prompts, I used the Prism. So the Prism allows me to use the set of data that I'm using, like test cases, and I'm running the same prompt with the different set of data, and I see what the output. And then I'm working with this output. Like I see, okay, this version of prompt is performs well. Let's try to adjust this. After adjusting, I'm just passing the same data through new version of prompt, and I see like new output version. And then I can compare like previous output with the new output and decide, is it change worth it, or it makes it how it affects the output. So should I revert it, or should I just try to improve it later. So I've used just my own tool for this. I didn't use like the metrics or so on.
Okay, thank you. Thank you so much for being a speaker, for answering all of our questions. This was great. I hope that you also had fun. This was your first
Yeah.
time as a speaker at a dxTechTalk.
Yeah,
I
it was
hope
good.
that you
Thank you.
enjoyed the experience, and yeah, thank you so much. And I hope I will see you again at another talk.
Yeah, for sure.
And thank you all so much for being here, for joining our talk. I hope you guys enjoyed it. We will have another one about front end on May 28th. It hasn't been announced, but it will soon. So follow us on social media to make sure you never miss anything. We'll have some more backend events in the future as well. And we also have a call for papers at the moment. So if you want to be a speaker at an event in the future, you can apply directly through our website and our social media. Everything is there. So yeah, hopefully one of you will one day become a speaker. And thank you all so much. Bye bye.
Yeah, thank you so much. Bye.
Bye bye.